So yeah, we're going to talk about OpenConfig. We're going to give a good intro. Hopefully people can walk away with this with some information on OpenConfig and a good demo and enough to actually run this on your own laptop and such. My information's here. If you have any questions, feel free to also ask throughout the chat. I'll respond after this presentation's over and through the break room with the network automation portion. But the link is there. I'm going to quickly copy that down or eyeball it there. Just some disclaimers and before we get into this talk and who exactly I am. So I'm an SE with Arista Networks system engineer. I actually live in Pittsburgh, but New York City is like a second home to me. So prior to a lot of this, I was back and forth in New York almost every other week to work with a lot of large financials and such in New York City. That's myself in the upper right-hand corner when I did have hair. My 4-year-old gave me a quarantine haircut. So you can see I do not have much hair left. I'm sure most of us have had the same. But I work on a lot of random automation projects. I've been in the industry for quite some time. So I have the typical battle scars most of you have. Now, as we go through this, like I have a real love-hate relationship with OpenConfig. It's a very good technology, but at the same time, it's a little bit difficult. So here's our disclaimers. So it's pretty complex when you come to managing devices with configuration. So a lot of this is only applicable to maybe 10% of customers. 90% of people can get away with a lot of this with a source of truth and a data structure with Ansible, or just typical Python Golang and that sort of thing. OpenConfig's really for robots and coding. All examples we're going to use here in the demo, they're actually through containerized EOS. So I work for Arista. Our operating system on a network is EOS, Extensible Operating System. And we take that and put that in the container so we could do demo purposes like we're going to do today. But everything's in the Git repo to get that going. Most of the things or anything I typically say, this is better, that is better, this works that way, and so forth. A lot of it's purely opinionated. I'm going to give you factual information on OpenConfig, but if I say things are better and such, it's just basically because that's kind of what I see in the field with most of my customers. And just lastly, I suggest going through most of the GitHub repo for a lot of these because it's brand new to most people, even though, depending who you ask, OpenConfig is sort of new, but it's been around for quite some time. And some programming knowledge is necessary because a lot of this is done in code. All right. So what do we solve with OpenConfig? Like, why does OpenConfig exist? So this is a JSON API. You're a typical network engineer. You're trying to get back a response from a network operating system, as in your BGP information. So you can see here within the JSON element that we're pulling back a router ID, peers, and just some basic BGP info. And this is typically what JSON would look like out of a vendor API. You work with another vendor, another network operating system, and it might have XML encoding. So you're getting the same information you want to about BGP. It's just going to be an XML encoding instead of JSON. So it's going to be the exact same information. And then lastly, you move on to a third vendor, and same exact thing. You want to get your BGP neighbors and just basic BGP information about that specific device. The problem you could see here is that even though the first and the last are JSON encoding, JSON really doesn't have a set structure. It can really put keys and elements anywhere you want to. So it is a problem when you are writing code to talk to network devices or manage them or even build a data structure for them. It makes things very difficult with every vendor having a different API. There are things out there today like Napalm that do a really good job, and this kind of solves a lot of that. So here's OpenConfig when you talk to a device. Even if you've never touched OpenConfig or seen it, realistically, network device 1 might be a Arista platform. Network device 2 might be another platform. But if you wanted to capture or at least query or get network interface stats on something, typically this is what it would look like. Now, if you look at device 1, you could see that in a pretty beautiful looking JSON where you get your octets, errors, pretty much everything that would be on a standard interface that you would care about for management. Same thing with network device 2, and they're pretty much the same exact thing. They are the same exact thing. This is really the promise of OpenConfig. The promise is that you have one API across everything that has the same exact data structure. So imagine if you had thousands of devices, it's very hard if each one has a different type of structure for the API. OpenConfig gives the point where you're going to have very good JSON information about a structure about that device that is going to be the same across any platform. So what exactly is OpenConfig? Now I kind of gave those demos. So OpenConfig is an industry standard vendor neutral for all your device states. So it could be state for configuration. It could be state for models change and so forth, but imagine just one repository of models that's open that you could apply across everything. Now, the neat thing is everything's driven by operators. So you as an operator, if you don't have a model specifically, like for a very, very long time, multicast was not supported by OpenConfig. And it was kind of a complaint. So a lot of operators, people specifically had to go to the OpenConfig working group, which is pretty much a Google group. And it's also, they have their own repo on GitHub. You pretty much go and you tell them what models you're interested in. And you propose a PR, a pull request to put in your own model and kind of vote upon that and push that through. And it's really neat, like as an open source project, to push models in as an operator. So things that'll help you out and do your job better. But just in general, like a too long didn't read is it's an API that runs across everything. It's really just a data structure. And as we drill into this, you'll see OpenConfig really, to clear up any confusion, it's realistically a data structure to describe the intent of your data. And along with that comes Yang. You'll see the picture I have here, I just went to Google Images, found a model and threw a switch on her face. So kind of funny. But Yang and netconf, you'll typically see these mentioned in the same sentence. And Yang's not the same as netconf. Netconf is basically a transport. So just to clear up any confusion, and it's one of the first ones that came out. We'll get to the transports eventually. But Yang in general is just a schema. So if you're unfamiliar with the schema, a schema basically says that something has to be a certain value, strongly typed or typed. So for example, VLAN, that's always going to be an integer. So it's always going to be a number. It's never going to be a string. It's never going to be a float and so forth. It's always going to be a number from 1 to 4096 and nothing else. So the structure, the schema has to tell you that. So we'll get into how to make Yang models, the construct, transferable into JSON or transferable into code. We're going to use something called PyYang. You can also use something called YGOT. PyYang is basically the same thing that's in Python, so Go. It's not anything new. Like this has been around for quite some time. So it's not a newer technology. It's been around. And then just lastly, like it's actually really neat. Like some of the OpenConfig projects I've been involved with and have seen, because typically you would think this is just for data center, routers, switches, and so forth. But it's making like a huge splash in the Wi-Fi community. It's very neat. So this is where you find all your OpenConfig Yang models. So there's two different types. There's basically an IETF, which has the IETF governance on top of it. So they decide what models go where. And then there's the OpenConfig Yang models, which are decided by operators. So you go and push PRs and go through the group and decide what to put on here. But you could see some pretty basic ones on here, just a truncated snippet. Things like BGP, things like LACP, MPLS, typical things you would use in your day-to-day job. So here's what a schema will look like. And I have just a little bit on here just to kind of explain what it looks like. The very first I've highlighted in red, that is the actual BGP OpenConfig.yang model itself. So a leaf is basically something that holds data. It's just a key value pair. So AS is going to be the key, and the value is going to be a strongly typed OC-INET AS number. So OC-INET is actually another model that's imported, and AS number is inside of there. But basically what that means is that even if you don't know the schema, how it works, that every single time this is going to have to be AS number, which is going to be a number. Router ID, same exact thing. So dotted quad decimal, it's going to have to be an IP address. Now, a neat thing about these models is that you import one from another. So obviously that's BGP. There's a really large common one called network instance model that basically takes BGP, MPLS, OSPF, IS-IS, all these things, and kind of combines them into one large model. So you could then specifically create a larger model off of that. But it's kind of similar to like the way a programming language would import different codes and libraries. But here's your end goal. Like you want to have an intent of your data. Like you want to have a way to structurally model your data across everything, and you want it to be universal. You want it to be everything to be the same. So even if you didn't know OpenConfig, I have a picture of 3 different platforms. So device 1 might be one network OS, device 2 might be another network OS, device 3 might be another network OS. But essentially what happens here is that you get the same exact data structure to model your BGP configuration across all your platforms. So that way, like your external tooling can go and talk to this, or even as a user, you can go in and configure your devices to be exactly the same, swap out vendors, that sort of thing. But it's extremely consistent. So how do we get to the JSON? Like how do we get back to where we were if we're just talking about schema? So there's something called PyYang. So effectively what PyYang is, it was spun out of Google, and the creator works for Google, hugely into OpenConfig. I highly suggest watching some of the vNYNOG video he did quite a while ago about this. But effectively what happens is you take PyYang, which is going to be a Python library, and you point it, I got a slide here on that, but you essentially point that to where the Yang model is. So OpenConfig network instance.yang, that's a Yang model. And you also too, with this argument, -o OC bind, effectively what that does is that creates a Python file that you're gonna import into your code, and it's gonna create all the constructs of that schema into Python objects. So like you're gonna get one massive class for BGP, and it's gonna have different things underneath it, which might be like neighbors, router ID, AS, and so forth. And here's a quick snippet of that. The code's sort of kind of irrelevant, but basically you can see import OC bind. Oop. Import, go back here on Google Slides, maybe not. But you got a Yang tree. Okay, here we go. Import OC bind. We could see that right there. And then basically you point to this class here. And once you dir it out, you get different objects that live within either PyYang or just in general. But what's really neat is like the binary itself, it comes with like a tree functionality or a tree argument. So effectively what you could do is like, since you're importing, like we had before, since you're importing all these different Yang models in one, like you as a human have to have a way to not really lint, but actually see what all is in the model. So you can just kind of point PyYang at a model and kind of see what's in there. So once you do actually start writing code to generate all the JSON files for this, you'll see them under here. Like the demo we're gonna do today, like you'll see, we'll typically just set a AS number and a router ID. But you can just keep drilling down into it. Here's a little bit more of complex code. We'll just briefly go over this, but effectively what I'm doing here is that I'm importing OC bind, which gives me that class of everything for that. And just kind of giving specific things you would do to configure a device or create a data structure as usual, AS number, peer AS, router ID. And then the main function, we just kind of go in and fill in the blanks. At the very end, we print it. And even if you don't know OpenConfig, like you could take a look at this and say, oh, okay, this is going to be a data structure that actually describes a device. So once you do have all your information as far as like a data structure, you could then model your entire network and kind of add to that. So every different change you would add to the data structure and then have something else push it back out. So you could then model an entire infrastructure. Here I only have 2 spines and 4 leaves, but I think I'll get the point is that you have a modeling language or an intent data of specifically all your devices, which is pretty neat. And it works across everything. Now, this is usually the end goal for most of my customers, and at least who work with OpenConfig in general. The whole typical idea is like, if you have all these OpenConfig models, which I just modeled BGP, for example, but you can grab any one of those, and you typically model an entire config or the parts that are that you want to change. And typically what you do is you expose those via a RESTful API so that the client or your external tooling can talk to that, pull back that JSON, and configure a device or use it for some kind of external tooling. And that's kind of what we're going to do in a quick demo. So here's my demo environment. I have container EOS connected back and forth like this. I basically have a Docker container which runs Flask. And if you're not familiar with Flask, basically it's a Python web framework that serves up content. Well, in this case, it's static content out of here. So once I create all those little JSON files with PyYang, it's going to serve those up. So let me jump into the repo here. Of course, updates. So here's the repo that has everything within it that was in the first slide. So I'm going to go ahead and just cd into OpenConfig. Oop. Lots of stuff right in here. So PyYang and then BGP and the rest. So that OC bind file is really big. I would love to do it in a demo, but it just like takes like a very, very long time, unfortunately. So let me just go ahead and get to the Yang tree. Mac. All right, so as I put that command in, we could see everything on the Yang tree. And we could see it has to go down, BGP, global config, router AS, ID, all those things are there. So the very first demo we're gonna do is we're actually gonna configure BGP. And then we're going to throw that at the API and then serve it up and take a look at it. So you can see here, like we import OCBind, or from that class, OpenConfig _ BGP from OCBind. And that's a massive file. It actually almost wants to kill my computer when I do bring it up, which is unfortunate. But once we point that class, we go into that class, take a look at it, and add AS number 1, router ID 1.1.1.1, and then we start to kind of add neighbors. And once we're finished with that, PyYang itself has like its own version of JSON output it prints out to. And we basically print that out. And the very last thing we do is we save it to where we're doing our, where we serve our static content. But you can see everything there. So Python 3, BGP basic. And we get this exactly here. So it's going to be exactly what we talked about before. This is typically how you would make your data structure out of PyYang. And it's a lot more complex than that. But like I said before, I'm actually running our container EOS here, and I'm running this Flask app here. So if I curled demo.json, which is the file that, oh, forgot my port. I'm going to get back all my information, which will be in here. So typically what would happen in this scenario is that a user would then take this, a configure device with it, with that encode usually. So now that you have that information, the next thing is like, how do you configure a device? So I have this really good transport, or I have this really good data structure that has on my device and it works across everything. So how do I then configure a device is probably what you're asking yourself. So typically today, like we have vendor APIs or just APIs in general. And I've seen a lot of different use cases where people actually take Ansible or Python and use that, render the config to vendor CLI, and they're on their way. So that's a possibility, but not really something you see a lot of. Netconf is almost considered legacy at this point. It is being used by a lot of legacy type tools, and some people do prefer it. But basically, you take this data, it has to be in XML and not JSON, and you actually configure a device with it, like through SSH, and it's rather legacy. It was one of the first transports. RESTconf is exactly what it sounds like. So RESTconf is taking this data as JSON and then sending it into a path to configure a device or get information back from a device. So gRPC is, in my opinion, the most common, and typically what 90% of these use. I do know of one customer who's using RESTconf I work with, but gRPC is the way to go. So gRPC, for those who are unfamiliar, we're going to explain how this works in a little bit here, but it uses HTTP2 and protobufs for like super high performance, and you could do streaming out of it. So it's just generally a very, very nice protocol once you marry the two. All right, so we're going to talk about RESTful API as a transport and why gRPC is probably most likely better for most people. But this is what we're used to when we're talking to a network device. So a client will send out any one of the HTTP methods. In this case, it's GET, talks to the switch, pulls information back in JSON, and then you're happy with that. And it's not stateful. It's obviously a REST API. So gRPC is very different. So gRPC takes a more of a programmatic approach to this. So effectively what you do is you have what's called a protobuf. So a protobuf is a very well-defined, almost like a schema that'll tell you what certain fields are within the protobuf and what they should be within those fields. And what you do is you actually import that. You have to have protobuf, the proto compiler, and you effectively import that into your code. And what you do is you invoke these methods where you pass in data. In the GNMI case, that data is just the Yang model. It serializes the data, and then on the other side of it, it deserializes it, and then the switch will get it, or the application will get it. This is actually a very good practice. So like Google, it's pretty much a Google thing, like, and that's why you could understand OpenConfig and other applications that use this. It's very good. It's very high performance. The issue between the two is that typically, like, once you serialize data on the wire, you're not going to be able to see it without a protobuf. The good thing about JSON data is once you actually do send it across the wire, like, it is actually readable. And in general, this is actually readable by any human. So what is a protobuf, and how is it different from JSON? So like, if we were working with the API, the JSON payload sort of looks like this. So like, you have info as the element, and then you have name and role. in protobuf language, you have or protobuf schema, you have a file. So I'm going to call this devices.proto. And we're going to see inside here, like this is pretty much the exact same thing. Like you have info, and then inside info, like you have two different fields, field 1 and field 2. So name and role, and they're strongly typed. Like it has to be a string for both of these. But you can basically fill this anything you want to. The whole thing is that anywhere in the application is going to have this proto file in its specific language. But effectively what you have to do is you have to compile this. And the really neat part is like that I'm leaving out here a lot is that you could do this in Python, you could do this in Ruby, you could do this in Golang. You don't have to import a specific, like Python uses requests, for example, to talk to an API or so forth. This, you just typically compile a protobuf, and then what you do is you work with it in code. So we'll give a quick example of how this works. So let me clear out of this. I have everything within the Protos folder. So GNMI, which is the gRPC service for OpenConfig, it's in here. But we're just going to use this because I think this is probably just generally a really good example because it's just really easy to read. So the first thing we're going to do is we're going to compile this. I call this devices.proto. So info, like I talked before. And the part I left out in the slide is that this exposes a gRPC service. We call this device information. Basically, a method's called network. You pass in info and it returns info. So you see info's here. So you call this method and you pass this in and it returns it back. But basically, there's a server on one side and a client on the other side. So let's go ahead and do that. Oh. Try it again here. And we'll see it created those two files. So like devices, gRPC, and then just the regular protobuf that holds everything. So I do have a server, and effectively what the server does is it will just create a server on localhost, and then I have a client, which effectively what it will do is it will just create what's called a gRPC stub or a channel to localhost as well. All I do is I pass in name and role of Arista, and let me do that. And I print it, whatever the protobuf is. And then what I do is I pass it through the channel or the stub, and then I print it afterward. So let me start my server here. All right, so starting my server, let me jump back into my IDE here. Start my client, and it should do exactly that. So it passes that in. Now I have some small bit of logic that basically says, okay, if leaf is not role, then just return it's something else. So if I go back here and I change this to like spine, for example, save it, try it again, it's going to say something other than a leaf. So why is this important? Why am I showing a quick gRPC demo of how this works? It's because typically OpenConfig itself, when you use gRPC as a transport, it's exactly that. And the GNMI spec is a little confusing because the actual protobuf file for that, it's 100 lines, but it has things like enumeration, streaming, all sorts of things that are pretty complex. I just think that's a good example because it's very simple and easy. But here's how you actually do configure with gRPC or with the GNMI service. Effectively, the client is going to pass in Yang models to that GNMI service, and then it's going to get serialized and it's going to hit the switch. So other vendors do the exact same thing we do, but obviously I know how we do this, but we typically just run all the time an OpenConfig server that runs in the box on port 6030. And within the OpenConfig or that GNMI server, effectively all it does is imports those protobuf files so that you can make this work. So it's pretty cool. Here is the GNMI service itself, and we'll get into like how to configure this. We're going to use our GNMI binary. That GNMI binary is neat because you can use it for pretty much any vendor that supports a GNMI interface. Here's the methods or the RPCs you're going to care about. So like before, how we looked at the network info gRPC service, same thing here. Like, so there's an RPC for capabilities. So effectively what you could do is like have a piece of code, go out there and ask a switch what Yang models it has. whether they're version 1 or 2.0, and specifically all the different paths, capabilities will give that to you. You can see here, you pass in capability requests and you return it. So you as the user will get that back. Get is going to give you information on a specific path. So in the demo here next, we're going to actually get the BGP information and we're going to return the get response to get that back to us. Set is exactly what you would think it would be. Like set, we're going to use set to actually configure a device, and then it'll tell you if it was configured or not. The big one here that is the huge benefit to a lot of this is subscribe. So when you subscribe, you'll see the keyword stream. You'll send in a subscribe request, and you'll just keep sending information until the other side doesn't get it and just streams it all the way back, which is primarily one of the best parts about gRPC or the GNMI interface. Once again, here's our demo environment. We have everything connected like that. And we're going to basically grab one of these files, configure it with a GNMI binary. So let me go ahead and, oh, come on, Zoom. All right. And in the bin folder, like this is where I have a lot of these. So you'll see here, for example, GNMI, which is our binary from Arista. But this, like I said, for this work and everything. And since a lot of network people typically work with Python in general, there is a Python one as well on the GitHub repo. So if you want to play with that, and that's all through Google through what's called GNXI, and I have links to that as well. So if we go ahead and we try to talk to our devices, like I said before, here's CEOS image 1, here's CEOS image 2. Let me just into this. Shouldn't have anything, which I do not. So let me go ahead and do a get of, like I talked about before, of the BGP config. So you can see here in OpenConfig, this kind of gives us what we were looking at with the model, just doing a simple get. So you can see get right there of that. And there's really nothing configured, but there are some things like router ID automatically assumes loopback 0. But other than that, there's no neighborship or really anything else. So we could do a get for all the paths, for example. So let's just grab all the paths and it'll automatically get everything that lives within OpenConfig. And the last thing we'll show here quickly is the streaming capability. So it'll stream as things come in, and we'll see it as things change. So like anything pretty much. You can see CPU utilization. You'll see like interface counters pop up here and there. But lastly, what we're going to do is we're going to configure BGP. So I had done this before. I just quickly go through this, but this file here configures CEOS1 with BGP.json. And that's basically just an OpenConfig data structure that does exactly that. So we'll go through, we'll configure it. So you can see here, replace as the rest of it. And same thing here as well. And if we hit the up arrow a couple times, where was our BGP? We'll probably see here that we have neighbors, hopefully. You can see AS, router ID, and such. And scroll down a little more, we'll start to see neighborships as well. So you see neighbor. But if we ultimately cheat, and we do cheat as network people from time to time, if we go into the actual device itself, take a look, we can see that it did form BGP, and it just came up 30 seconds ago. So it's pretty cool. Like I said before, like this is all vendor neutral, so like that exact code would pretty much work on anything. I do have slides from this, hopefully, or I do have links from this because I think OpenConfig is really complex and there's a lot to go off of. So I believe these slides will be distributed, but here's some links on honorable mentions. There's a lot here to go off of. So thank you.
All right, thank you, Daniel. So if anybody has any questions for Daniel, now's the time to post them in the chat and he will answer them. So we'll give everyone a minute or two.
Hey, Dan, I actually had a question in the meantime. Just kind of generally, what do customers do if something in their environment is not supported by OpenConfig, today? Is their answer to contribute to the project? Do they fall back to an API? Like, what options do they have?
Yeah, no, excellent question. So effectively, like there are going to be vendor proprietary streaming objects. So what we did, I thought was really interesting. Like, so for the longest time at Arista, we had a OpenConfig streaming daemon, which we just showed. And then we had something called Terminator, which kind of gave you raw access to all the devices. It gave you a data structure that was proprietary towards us. What we did recently, probably about 6 months ago or so, we actually combined the APIs, which is actually pretty neat. So if there is something specifically that's not within OpenConfig, you can actually grab that path out of us. Now, if you are looking to get that just out of OpenConfig, you would have to exactly do that, which would be subscribe to the Google group and then talk about what you want and what you're needing exactly. And then you just put forth a PR to them and they could do exactly that.
Cool.
All right, so Daniel, there was a question posted in the chat from Terry. Looks like it was asked and answered. Don't know if you want to chime in on that question.
Yep. Yeah. So actually, about Telegraph and Influx. So you have Damien on here who did a very, very good presentation, vNYNOG doing exactly that. So what was very neat, and I think what helped out the network industry a lot, Telegraph came out with a plugin for GNMI specifically. So you just go in and subscribe to paths in which you care about, and it'll push that data back into time series. Typically, it's Influx most popular, and you can graph all those counters as you wish.
All right, and there's 2 more questions posted. If we can just hit those 2 real quick.
What is your view on optical transport OpenConfig versus? I do not know. I am not an optical person, so I could not answer that question. How do you fit this into a wider flow for continuous? Yeah. So if you were to port this into a CI/CD model, basically you make a change to your structure. So you would typically have that data struct out there somewhere. You would have that data struct out there somewhere as a GitHub repo or a Git repo, for example, and you would make a change to that, and then you would kick off the whole CI/CD pipeline, which would do exactly what it should do once you have it. But all your code essentially would be as a data struct in CI/CD. Nick, that's very funny. No, I don't think anyone likes Windows containers.
No, that's a good note to end on. So we'll leave it at that. Thank you, Daniel. Thank you for the great presentation.